Hey guys, this is Mr. Sal. This is the Unit 7 review, webbing it together. So it really is just a review of all the other units, except for some distribution and some order of operation stuff. Alright, so we are going to apply the distributive property on these. And just to get us started off, you don't have to use the distributive property on the test, but if it helps you to do these ones, then so be it. So on this first one, this would be first, which show is 2 times 3, and then we're going to add the 2 times the 7. And 2 times 3 is 6, 2 times 7 is 14, which when we add these together is 20. So like I stated in the last video, is we may be going through these a little quick. That's because we expect you guys to know them. We shouldn't be doing the review without you guys having completed the homework. So at this point, if you're like, man, this is going really fast, or if it's really hard for you, go back and do the homework, study it again until you feel like you've got it down. Then hopefully it won't feel like we're going so fast. On the next one, since it's not addition or subtraction for this one, we still will distribute, but you would have to perform the order of operations first. 3 times 7 is 21. And now I'll multiply this by the 2. 2 times 21 is 42. So this 42 is our final answer for this one. Alright, so for this next one, it says to use the distributive property, so you could just basically multiply these out, right? But we'll do it the same way that we did it in the classwork, which would have been, in this case, 5 times expanded 42 would be 40 plus 2, right? So I've got 5 times 40, which is 200. And then I've got 5 times 2, which is 4. Combining these together gives us 204, which would be our final answer here. So we'll do the same method on this next one. We're going to do 70, and we're going to multiply that by 300, then 20. Alright, now I don't need the 0 in the ones place because it's just multiplied by 0. Anything multiplied by 0 is 0. So distributing the 70 times 300, it's going to give us the 3 zeros. 7 times 3 is 21. Now 70 times 20, that's 2 zeros. 7 times 2 is 14. And again, we're simply adding these together. So 21,000 plus 1,400 would be 22,400. Next up, we'll use the order of operations on these. So remember, it's PEMDAS, right? But not always PEMDAS. There we got, remember, it's parentheses, exponents, but then it's either multiplication or division from left to right, and then either addition or subtraction from left to right. So in this first example that we see, we have to do the subtraction first because it happens farther to the left. 12 minus 14 is the same as 12 plus negative 14. There's more negatives than positives. 14 minus 12 is 2. So now it's negative 2 plus 3. Now when I combine these, I get more positives than negatives, and 3 minus 2 is 1. So that's the answer for 3A there. Next up, we got multiplication and division. Going from left to right, we must do the division first. 48 divided by 8 is 6. Now I can multiply that by 2, which is 12. So the answer to this one is 12. Again, just please do not get this mixed up. Don't do the addition first. Don't do this multiplication first unless it's farther to the left than either the subtraction or division. So on 4A, same idea, but this one has multiplication first, so 2 times 3 is 6. Now 11 plus 6 is 17. And that's the final answer for that one. In this next problem, we got parentheses first, so we got to do that. 6 minus 9 is the same as 6 plus negative 9. There's more negatives than positives. 9 minus 6 is 3. So I've got this in parentheses. Now it's to the power of 2, which makes this negative 3 times negative 3. Now, at this point, we have two negatives. 2 is even, so the answer is a positive, and 3 times 3 is 9. So we'll just end it like that, with the final answer being 9. And remember, it's not necessary that you show the positive sign for positive numbers. Alright, for this next set, we're just following the order of operations. I see parentheses in this first one, so I'll do the 5 plus 3, which is 8. So the rest of that would read 8 to the power of 2 minus 7 plus 2. And then I move on to my exponents. 8 times 8 is 64. So now I have 64 minus 7 plus 2. Now on to multiplication or division, there is none, so I'm going straight to addition and subtraction from left to right. So the subtraction first, 64 minus 7 is 57. So I've got 57 plus 2, which is 59. And that's the final answer for this problem, 59. Now this next problem, there's no parentheses, but there is a set of square roots, which is the same as parentheses. Square root of 144 is 12. So 12 minus 36 divided by 9 times 2. No exponents on this one, so we'll go straight to multiplication or division from left to right. So I've got the 36 divided by 9, which is 4, because it's farther to the left. And now I've got some multiplication. 4 times 2 is 8. So I end with 12 minus 8, and I've got subtraction now from left to right. 12 minus 8 is simply 4. So my final answer on this one is 4. Now on to number 6. If I saw this division problem, or the fraction line right there, I'd just cross out the zeros. 9 divided by 1 is 9. So now I have 9 minus 3 to the power of 2 plus 2 times 3. And yes, we do have the exponent. 3 to the power of 2 is 9. So no more exponents, but we do have the multiplication there. 2 times 3 is 6. So 9 minus 9 plus 6. And we're on the addition or subtraction from left to right. We've got the subtraction first. 9 minus 9 is 0. 0 plus 6 is 6. So this is our final answer there on 6A. So for 6B, I'll make this one a little bigger so we can see it a little bit more clearly. Now we got this set of parentheses, but within inside that set of parentheses is another set of parentheses. So I do need to do those first. 15 minus 7 is 8. So now I have this expression, and I'm going to be looking for my exponents, the 2 and 3 there. So 3 to the power of 2 is 3 times 3, which is 9. And 2 to the power of 3 is 2 times 2 times 2, which is 8. And these will be multiplied together. Now, just right now, inside this set of parentheses here that I've highlighted, there's no more exponents, but there is some multiplication right here with the 9 and 8, which is 72. So now I've got 72 minus 8 in the parentheses, which is, let's see, it should be 64 there. So that kind of finishes off that set of big red parentheses. And I'm left with 64 divided by 2, which is division on the outside. 64 divided by 2 is 32 right there. So final answer on this one is 32. Alright, for these, once again, back to the order of operations. So we got this set of parentheses here, 2 minus 3. That's going to be negative 1. But then I've got this exponent here with a 2, which is really negative 1 times negative 1. 2 negatives, 2 is even, so the answer is positive. 1 times 1 is 1. So now there's no multiplication or division in this, so I'm going to go straight to subtraction, which is farther to the left. 1 minus 9 is negative 8. Then I will add the 4. Still addition, negative 8 plus 4 is negative 4, which is our final answer on this one. On this next problem, I would focus on the numerators and denominators separately. So in the numerator, got 5 times negative 8 there, which is negative 40. And that's as simplified as the numerator can get. But the denominator, we've got to do the exponent first. 2 to the power of 3, which is 8. 2 times 2 times 2. So then I would be looking at the multiplication here between the negative 3 and 4, which is negative 12. And then we'd do the subtraction there with the negative 12 and 8, which really could just be negative 12 plus negative 8, which is going to give us a negative 20 there. So right now I have a negative 40 divided by negative 20. And this now is at the division stage. Zeros can cancel. I've got 2 negatives, so I know my answer is positive. And 4 divided by 2 is 2. So this is my final answer for this problem, positive 2. Alright, 8a is similar to that last one. We got to focus on the numerator and denominator separately. So I'm going to focus first on the numerator. But again, you could focus on the denominator first. So I've got this multiplication there, the 6 times the 2, which is 12. There's no parentheses or exponents there. So now this would be like 8 plus negative 12. So I'm on the subtraction part of that. 8 plus negative 12 would be negative 4. Now the denominator, which only has subtraction and addition, the subtraction is first because it's farther to the left. 3 plus negative 9 is the same as negative 6. So I've got negative 6 plus 4. There's more negatives than positives. So I know my answer is negative. 6 minus 4 is 2. So I've got 4 divided by 2. Now we're on the division portion of this because the fraction line is a division sign. There are 2 negatives. 2 is even, so the answer is positive. 4 divided by 2 is 2. So the final answer for this one is 2. Next up, there's there's a couple exponents on this, right? So I got negative 2 times negative 2 times negative 2 first. Now this is an there's an odd number of negatives. An odd number of negative makes the answers negative. 2 times 2 times 2 is 8. And then over here, it's going to be subtract whatever 3 times 3 is, which is 9. Now again, we could make this a negative 9 if we wanted to, which is going to make the answer more negative. 8 plus 9 is 17. So this is our final answer for this one. Alright, now remember on these ones, if you wanted to simplify the fractions on the inside of the parentheses, you could, like the 6/10 could be changed into 3/5. I'm not going to do that. What I am going to do is keep it the way that it is, but I am going to expand the 2/3. So this would make the 2/3 as an exponent 2/3 times 2/3. Well, now we can do any cross simplification that we want, such as the 6 and 3 there would be 3 and 1. I'm sorry, 2 and 1. There we go. And then the 2 and 10, the 2s like this 2 and this 10 could be combined to give us a 5 and 1 there. Now there's no other simplifications that we can do on this. So I'm going to multiply all my numerators. 2 times 1 times 2, which is 4. And then the denominator, 5 times 1 times 3 is 15. So this is my final answer for this problem. Now that's nice when it's straight multiplication. If not, then it is going back to the order of operations. For example, 1/2 times 1/2 is 1/4, right? I'll show that 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. So this is our new problem, and we're going to run into a problem with the denominators, right? We can't add or subtract fractions without common denominators. In this case, it looks like the best common denominator for us is going to be 60. So I'm going to change all these fractions to denominators of 60. Now it doesn't change the operations, that's fine. But now we got to figure out what we multiply these by to get 60. 15 times 4 is 60. So 8 times 4 is 32. 3 times 20 is 60, so 1 times 20 is 20. And then 4 times 15, we just saw, is 60. 15 times 1 is 15. So we have this problem now, and this is going to give us a common denominator of 60, which is great. And we'll operate with the numerators 32 minus 20 plus the 15. And I'll just use the space to write the answer. And yeah, we'll see if this can be simplified, but I don't know if it can yet. 32 minus 20 is 12, plus 15 is 27. So yeah, this can be simplified. Both of these are divisible by 3. Maybe even more, I guess. We'll find out. But 27 divided by 3 is 9. 60 divided by 3 is 20. So no, that would be our final answer for this one, 9/20ths. For this next problem, we got the 1/2 divided by 2/3 times 10/12ths. And yeah, you could start simplifying those fractions if you could, the 10/12ths specifically. But I'm going to change. I'm just focusing on the 1/2 divided by the 2/3. I want to change that to multiplication by reciprocating the fraction. So we'll reciprocate that and make that 3/2, which when multiplied gives us 3/4. Now this was multiplied by 10/12ths, and it looks like we could, if we wanted to, simplify the 10 and the 4, which would be 5/2, and the 3 and the 12, which would be 1 and 4. So this is as simplified as I can make it. Now we would multiply. 1 times 5 is 5. 2 times 4 is 8. So after all that multiplication and division, we get 5/8. Alright, now some applications. A food company has 3 manufacturing plants. It has 329 employees in Idaho, 982 employees in Alabama, and 1,123 employees in Ohio. How many employees does the company have in total? So we're going to start with Idaho, which has 329. We have Alabama employees at 982. And then the Ohio plant with 1,123. Now, since we're figuring out how many employees total does it have, we're just going to add these together. There we go. So 9 plus 2 plus 3 is going to be 14. Carry the 1. 1 plus 2 plus 8 plus 2 should be 13 there. Carry the 1. 1 plus 3 plus 9 plus 1 should be 14 again. Carry that 1. 1 plus 1 is 2. So 2,434. Again, the label for this one, we'll just put employees. All right, next up, Lisa earned $1,800 last month. She spent 2/3 of her income on rent. How much money did she spend on rent? So she earned the $1,800, but she spent 2/3 of that. So it's really multiplied by the 2/3, which means it may be helpful to show the 1,800 over 1. So multiplying these out, right, would get 1,800 times 2, which is 3,600. 1 times 3 is 3. And then dividing these two would give you $1,200. And again, that's just how much she spent on rent. Alright, Ken wants to put carpet on his living room. The dimensions of his rectangular room are 12 by 14. How much carpet should he buy? Each square foot of carpet costs $8. How much money does he need to spend for the carpet? So 2 questions on this one. First, we want the square footage. So I'm going to draw a picture of the room. Doesn't have to be completely accurate. That doesn't matter. But this is a 14-foot by 12-foot room. Now, when I ask how much carpet we need, that's area. Okay, so we're going to take the 14 and multiply it by 12. And this will tell us how many square feet of carpet we need. So this comes out to 168 square feet. Now that's the answer to the first question right there. How much carpet should he buy? But then the second question says, if it's $8 per square foot, how much is he going to spend on this stuff? So it is the $8 per square foot, and you got 8 groups, or 168 groups of that. So we're going to multiply these out. We'll show it. 168 times 8. That's going to be 64, 48, 54, and 13. So this is going to be $1,344 to put carpet in this 12 by 14 room. Alright, Ron opened a bank account with $5,000 initial deposit. For the next 2 years, every month, he withdrew $40. How much money will he have left in the account after 2 years of withdrawing $40? So we have the initial amount at $5,000. And we're going to subtract $40 every month for 2 years, right? So 2 years is 12 months. 12 times 2, which is 24. So this is the expression as we have it. So how much money is he going to have withdrawn after the 2 years? That's 24 times the 40. So we'll multiply this out. So it looks like the 2 years, withdrawing $40 every month for 24 months, means that he would have withdrawn $960 there. So now we got 5,000 minus 960, and again we'll show the work for that. 5,000 minus 960. So after 2 years, it looks like Ron would have $4,040 in his account. Alright, then we're looking at averages. Remember that an average is going to take the sum of the numbers and divide it by the number of numbers. So remember from 7.4, we did it like this, right? So we're going to do these one at a time. I'm going to find the sum of all the numbers, or add the values together. 71 plus 82 plus 93. We're adding these. 1 plus 2 plus 3 is 6. 7 plus 8 plus 9 is 24, so that's 246. And we're dividing this by how many values? 1, 2, 3. So we're going to divide this by 3, right? So 246. And we'll divide this by 3. 3 goes into 24 8 times, so that's exact right there. And we'll drop the 6 to make it 6. 0, 6, 3 goes into 6 2 times. So the final answer for this one is 82. You could put points or whatever. It didn't really say what it was measured in, so a score, something like this, okay? Just so we know that the answer is labeled, and that would be the final answer for this one. Alright, so that does it for the Unit 7 review. Hopefully this was helpful for you guys. Remember, the test questions are usually patterned pretty closely after some or all of these. So you're going to need to know how to do all of them in order to do well on the test. If you can do well on all of these problems, we would pretty much figure that you could do very well on the test. But if there's any of these you struggle with and you don't learn it before you take the test, then we would expect you to struggle with similar problems. So just keep that in mind as you study, or if there's any of these that you're like, I'm not really completely sure how to do it, just go back to the section and then review the entire section and even maybe review some of the homework problems. Thanks for watching, you guys. We'll see you in the next one.